Alright, hey guys. Today we're taking apart a RYOBI Lithium 18 volt. This one is bad. So all you need for this one to actually take it apart, from what I know so far, is actually a T10. But not any T10. This T10 is the one, hopefully you guys can see it, which has the safety pin inside. So with that you can remove your 5 screws which hold your RYOBI battery pack together. So this is now all loose. Let's see if there's anything more which we might miss. I feel like there's something underneath here, but I could be wrong. Let's see if we can't get it apart now. Yeah, it's still holding on to something. So you can see something is coming apart, but let's see if we can't get it somehow apart. Ah, okay. No, there's no screw. It's just these clips. Alright, so there you go. Now it came apart. I ripped some plastic apart, which most likely is from the screws. And we have one pin here. Ah, okay, there's another one. Ah, okay, so that's what somehow holds. So they are glued together so that they are not meant to come apart, because these clips, hope you can see it, these clips seem to go in here and give it tension, but those clips are held down and welded down in here. So when you take the battery pack apart, this clip holds your upper part of the battery pack in place, and it does not come out very easily. So there is one of your issues with that. So if you want to replace the batteries and see what's really going on inside, there you go. So let me see that I get this one out. Put this one back in place. And in it goes, and in it goes. So these are your clips which hold there in place. But now comes the tricky part. So when we look at this and we look at the push button to see what is going on with your batteries, I noticed right away here on the side one weld, and yes, this is a weld. Let me see if I can get it in. That one is bad. It blew up. So most likely this battery is bad, because on the other side it looks good. But there you can see what batteries are actually inside of your battery pack on the RYOBI. So I hope you guys enjoyed this quick disassemble of the battery pack on the RYOBI. I'll take this further apart and we'll start recording more of this, and we'll figure out what is really going on and how can we repair it so that we can hopefully reuse this as well. So I see there's something underneath this soft rubber. Hopefully, okay, there you go. That is your temperature diode. So let's see if you guys can see it. There's your temperature diode, which is held in place. That actually is similar to what Makita does. Makita puts it here in between, so RYOBI puts it on the side. And the way it looks like this 18 volt pack runs, I'll have to take it all the way apart to figure out how everything is put in order. Not sure if this top comes apart. We'll take it apart step by step, hopefully not breaking anything. There has to be some sort of mechanism to it. But anyhow, so you have five 18650 batteries in it, and I see 1, 2 have discoloration. One is the one which has the bad weld, the other one is here on the top, and that can be that there was moisture coming in. That looks weird. But each of these batteries should be giving you 3.7 volt. Let me grab actually the voltmeter quickly. Alright, so battery pack, I got it a little bit further apart. So it looks like down in there, not sure if you guys can see, there's a piece of plastic, and there's 2 positive, 1 negative cable going to your connectors, which is correct. You have your positive here and your negative there and another positive. So let's see if we can't get this piece of plastic out of here, because there's 1 screw here in the center, and I have the feeling this stuff, yep, there you go. So if you put a flathead under here, you can actually work the connector down. Perfect. So all you have is pretty much pressed into this plastic this riser. This riser is holding in place on your motherboard here, and so you have, looking at this, looks like there's 1 pin. This one is called T1. Then the thick red one is battery plus, which on the back side is this one. And then you have your battery negative down there. So let's see what the battery is reading here at all. I have to do it this way so I can actually read to you guys what's going on. So 18 volt is ideally what you have, and right now when you measure you get 0. When you measure to your probe here, also 0. What is, if I go negative to here, here's another ground. Ground also is negative. So let's see, if we go negative here to battery here, that's flat. That's absolutely flat. Nothing there. A couple millivolt. 130 millivolt. I'm not sure if I can. 80 millivolt. 80 millivolt. So most likely negative, and here's a big positive as well. Yeah, this whole battery pack is completely dead. But if we use a good one in comparison, which is right this one, and I just charged it. I just used it barely, so let's see what we get. Let's see if we cannot line it up somehow so you guys can see it. Let me put this underneath. Can you guys see it? Yeah, you guys can read it a little bit. So positive, negative, I get 19 volt, which is about right. So 19 volts, so this pack is working. Nothing there. So 19.2 versus here 2.1 point. So these batteries most likely are completely discharged. Primarily I would say because there's one dead cell inside of it. So what I'm going to do is, there are 1, 2, 3, 4, 5, 6, as you can see there are 4 screws, Phillips screws here. Looking right now how it's soldered, so 2 positive going there, 2 positive going there. Here it says CL2 and there it says CL4. Over here it says CL1 and CL3. So it measures a cell pair at all times. And looks like they were welded in place, sandwiched together. These plastic units are put on first, then the solder is applied. Once everything is assembled, solder is applied. The positive least for the CLs, so for the battery cell packs, is pre-soldered in. I'm guessing your negative and positive here are the last of the assembly, because the weld tabs are welded onto the batteries first, and then at the end, most likely in China or wherever it gets assembled. Does it even say it on the bottom? Made in China, so yeah. These wires being soldered on by hand, that's what it looks like. 1 tab, 2, 3 here, 4 there, and then you have your positive lead here and your whole negative here. And so because it is daisy chained in the way, positive going to negative, negative to positive, negative to positive, negative to positive, so it pretty much does do a daisy chain the way it goes from here in a zigzag to here. So you should be able to measure from here to here, 19 or 18 volt once the pack is full. But you should be able to measure each individual on this pack because it's only one layer. So it should be fairly easy to find out which battery is bad. In this case, I think they are all sort of dead. But I will get to it. Yep. Made in China. It's not even in the guide here. Sort of in the guide here. Correct here, and this one I just pulled out. But yeah, that's pretty much your 18 volt pack. I'll replace these and get it reassembled together because why not? So I'll look up what this is. It's an LG HB, so it's an LG HB. And so I have plenty of the LGs, which are DAs, but these are S3s. And so what each are and how this Chinese, pretty much this code is being to be read. LG is for the manufacturer, LG, and then here's your model code, DAS3, and when you read that up you can actually then see what they are. So this one, for example, is a battery out of a laptop battery, so the drain, the amperage drain is relatively low. I would say it's maybe 8 or 9 amp, where in these battery packs, that's why they are so powerful, they are high drain. The problem with high drain is also that they're losing very quickly the energy, so they don't store long. Those are the same batteries you would want to use when you vape and actually use high draw. But that's pretty much it. Again, this is the RYOBI Lithium Plus, which I took apart, the 18 volt. Thanks for watching, guys. Have a good one.